Alright guys, so let's take a look at the function operations, okay? So remember, the idea here is that we are adding, subtracting, minus 1t, or multiplying two functions, okay? So what we usually look at is we see our two functions, okay? And then how they're going to be combined, okay? And sometimes we see them separated like this, sometimes grouped together like this, but it means the same thing. So basically we're taking this function g and we're going to add to it this function h, okay? So first thing we're going to do is actually write that down. So g is first, so I'm going to write 2x plus 4. I don't write the g of x or equals because we're creating a new function, okay? Then the h of x, which is x cubed plus x, and then we're adding them, so I'm going to add them together. So now what I look for is for like terms, okay? So remember, like terms, they have the same variable with the same power, okay? So even though I've got x cubed and x, it's the same variable, but they're not the same power, okay? So x cubed, there's no other x cubes, so I'm going to write x to the third first because we typically like to have the highest power first. Then I've got a 2x and an x, so those ones are like terms. So it's like a 2 and a 1, so 2 plus 1 would give us 3x. And then we've got that plus 4, there's no other 4, so plus 4, and that is our new function, okay? So g plus h of x is equal to x cubed plus 3x plus 4, okay? And that's all we're doing here for the first part, okay? So again, take our first function g, and minus 1, second function f, plus, right, because that's what we're doing, n plus 5, so like terms n and n make 2n, negative 1 and 5, that's 5 minus 1, give us a positive 4. It's positive 4, so I put a plus, okay? Number 3, now with minus, there's a little difference we have to do, but we started the same. So we write g first, so I've got 2x minus 1, okay? Then we're going to minus. Now, because we're subtracting this whole function. So if I just write a 3x minus 1, what I notice is that negative only applied to the 3x. It didn't apply to the negative 1. So what I like to do is I like to put parentheses here, and then we can distribute that negative, so we get 2x minus 1 minus 3x plus 1, and that would represent that subtraction. And then we combine like terms. 2x minus 3x is negative 1x. Negative 1 plus 1 is 0. I can just get rid of that plus 0, and I can even get rid of that 1, and just negative x is my answer. Okay, so my new function, negative x. Okay. All right, number 4, g of t. So g of t is 3t plus 4. Subtracting, and then I'm going to put parentheses, f of t, which is t minus 2. So that negative applies to both, so I end up with 3t plus 4 minus t plus 2. Then combine like terms. 3t minus t is 2t. 4 plus 2 is positive 6. So my new function, which if I wanted to, I could like call it h of t, would equal 2t plus 6. Okay, and that's pretty much all we got going on here for the plus and the minus, okay? So let's just keep on working. So f, 2t plus 4 minus 4, plus, in this case, t squared minus t. Now t squared doesn't have any like terms, so I go t squared. 2t minus t would be, 2 minus 1 is negative 1 or just minus t, then minus 4. And that is my new function, which we can just call it h of t or anything you really want to, okay? So number 6, now we've got a minus, so I go 4t plus 2 minus, parentheses, 3t minus 2. So that negative applies to both, so 4t plus 2 minus 3t plus 2. Okay, 4t minus 3t is just 1t. 2 plus 2 is 4, so t plus 4 is my new function. Number 7, h of t, so t plus 1 minus g of t, so minus 2t minus 3. So we get t plus 1 minus 2t plus 3. Negative 2t positive t is negative 1t. Plus 1 and plus 3 would be plus 4. And there's my new function. Now, there is another way you can think through this if you really wanted to. And let's look at number 11 to start us off. We'll come back to those other ones. But I could think of it like, remember when you did like, 12 plus 35, and you'd write it like this, and you would add the ones, and you'd add the tens together. We can kind of think of it that way. So if I do g, I've got 4x plus 2. So for h, I take that 2x and line it up here, the plus 2 and line it up here, and then I could add them. 4 plus 2 would give us 6x, 2 plus 2 would give us 4, and we have 6x plus 4. Okay? It would work with subtraction too. Okay, or again, I could do it this way, right? And get the same thing. But again, I could go g, a plus 3, then minus a minus 3. A minus a is 0a, which is just 0. 3 minus a negative 3, that's like plus 3, that would be a 6, positive. So I'd end up with 6 for my answer. Okay? So we could do it that way if we really wanted to, which again gives us the same thing if I do it the other way. Okay. Now, what if we have something like number 8, where now I've got this x squared? Okay. So the way to think about it is like this. I would write my f of x first, so x and then positive 3. Then I've got this x from here, and then x squared would be out here. Okay, because it wouldn't line up with the 3, so this would be like 0, and this would be like 0x squared. And we're subtracting, so 0 minus 1 would give us a negative x squared. X minus x would give us 0x, or just 0. 3 minus 0 would give us 3. So we'd end up with negative x squared plus 3 as our answer. Which, if we did it the other way, we can see we get the same thing. X's cancel, negative x squared plus 3. Okay? So, it works either way you do it. Addition is a lot easier. Negative 4x plus 4x is 0x. 1 plus 0 is positive 1, so an answer of 1. Okay, so we have x squared. And then it would be like 0x and then negative 3. And then we'd have 2x and negative 5. We're subtracting x squared minus 0. It's just x squared. 0 minus 2x is negative 2x. And negative 3 minus negative 5, it's like negative 3 plus 5 would be a positive 2. Okay? Again, if we did it the other way, we still end up getting the same thing. It's just a different kind of, same process, just written out differently. Okay? So that's kind of a way that you can deal with that, and we get the same thing going on there. Okay? So, let's keep on going. Now, these next ones, okay, now we should notice that we have a difference here, right? Instead of just a variable, and let's pull that up. Instead of just the variable over here, now we've got a number. Okay, so there's two different ways we can attack a problem like this. So I'll show you both ways on number 13. Then I'll just kind of flip-flop between the two different ones. Now, I don't care which version you use. I'll tell you which one I prefer, but when I do it, but you guys can decide for yourselves. Okay, so the first way would be to treat it like we did up here. first we would add these two functions. So I'd go negative 2x plus 2 plus x squared minus 5 plus x. Okay, so x squared, negative 2x plus x minus 1x. 2 minus 5 would be minus 3. Then I'm going to evaluate at negative 3. So everywhere there's an x, I'm going to put a negative 3. Okay, negative 3 squared is positive 9. Minus a negative 3 is plus 3 minus 3, which plus 3 minus 3 undo, and we're left with 9. So in these ones, you're going to end up with a number every single time. Okay, that's one way to do it. The other way to do it is to separately solve these. Okay, so let me erase these. Okay, so you can do it this way, or you can do it this way, where I'd go, okay, I'm going to solve for h of negative 3. So it'd be negative 2 times negative 3 plus 2, right? Everywhere there's an x, I replace with the negative 3. So then I evaluate. Negative 2 times negative 3 is positive 6. Positive 6 plus 2 is 8. So h of negative 3 equals 8. So I know h of negative 3 is going to be 8. And I'm adding to that what g of negative 3 is going to be. So I go g of negative 3 equals negative 3 squared minus 5 plus negative 3. Negative 5 plus negative 3 is negative 8. Negative 3 squared is positive 9. 9 minus 8 is 1. So g of negative 3 equals 1. So 8 plus 1 gives us 9. Now, this is the method I prefer, but it doesn't really matter which one you use, okay? It's completely up to you as to how you go about it. So again, you could do like number 14, and I could say we're adding them. So 2x minus 1 plus 4x minus 4 gives us 6x minus 5. Then I evaluate for negative 7. So 6 times negative 7 minus 5. 6 times negative 7 is negative 42 minus 5 is negative 47. Or we could evaluate them separately and go h of 6 equals 6 squared plus 4. 6 squared is 36 plus 4 is 40. So h of 6 is 40. Then evaluate for g of 6. So 6 minus 5 is 1. So g of 6 equals 1. So I go 40 plus 1, and I get 41. Okay, you're going to get the same result regardless, okay, of which one you choose. Now, I tell you I like the one where I evaluate them separately, and I like it for this reason, okay? Let's look at this subtraction one here. So let's do it both ways. So I've got n plus 1 minus 2n plus 1. N minus 2 is negative n. 1 minus 1 is 0. So I've got negative n. Okay, so then I plug in negative 2, so negative 2 would give me positive 2. Okay, now that one seemed pretty simple, right? Because the numbers were pretty small and easy to deal with. Problem is sometimes I mess up when I'm subtracting. So I like doing it separately because then I can go evaluate g of negative 2 equals negative 2 plus 1. Negative 2 plus 1 is negative 1. F of negative 2 is f of negative 2 equals 2 times negative 2 plus 1. 2 times negative 2 is negative 4 plus 1 is going to give us a negative 3. So f of negative 2 is negative 3, and I'm subtracting. So that's like plus 3, so I end up with 2. So what I like here is I don't run the risk of messing up this part when I'm doing this part. So that's kind of why I like to do the negatives like that, is simply for that purpose. But at the end of the day, it really doesn't matter if you go 2t plus t squared plus 2 and then plug in negative 6. In this case, it's a lot easier to combine them first, I think, than to do them separate based on what we have going on here. Okay? Whereas other times, maybe, especially with subtraction, then you don't mess up the negatives there. Sometimes it's easier to do it this way. Just kind of depends on which version you like. Negative 5 cubed is negative 5 times negative 5 times negative 5, which is negative 125, plus negative 5, negative 130. So negative 9 minus negative 130, it's like plus, gives us a positive 121. Okay, so like I said, it's really up to you guys how you want to do it, but that's pretty much all you got to go for, okay, is just doing it that way. Alright, so let's take a look at number 19. So if we combine these two together, let's actually do this one separate. So f of negative 1 equals negative 1 plus 1 equals 0. G of negative 1 equals 2 times negative 1 minus 3 equals 2 times negative 1 is negative 2 minus 3 is negative 5. So 0 plus negative 5 gives us negative 5. As opposed to n squared minus 2n minus negative 2n plus 4. So then we distribute that negative. Negative and a negative make a positive 2n. Negative and a positive make a minus 4. Those cancel out, right? Becomes 0n, so n squared minus 4. Then put a 4 in there. We get 16 minus 4, which is 12. Alright, so there's how we deal with those guys, the addition and subtraction of things, okay? Alright, there we go. Now let's talk about the multiplication. So, because I have the same assignments, I'm just going to split this up for those that had them split up into 2 different days and not split up for those that had them all together, okay? So, if they were split up, this would be number 1 for multiplication. All right. So yeah, if you're doing from the lab, this is like the multiplication, and this would be question number just 1. But if you're the regular class, this is just continued. So with multiplication now it gets a little different, okay? So the idea here is that we are still taking our first function, x minus 4, and we're going to multiply it by our second function, negative 4x minus 5. So the best thing to do is put them in parentheses, okay, like that. And the idea here is that this piece here is going to be multiplied by both of those, and this piece will be multiplied by both of them as well. Or you could think of it backwards, and this piece has to be multiplied by both of these, and this one by both of them as well. So basically every piece inside here is going to be multiplied by every piece inside here. Same with this one, okay, which will end up having these do the same thing. Okay, now we've got kind of a thing, not a trick, but a way that we can kind of think through it. And it's called FOIL when we're dealing with this. And we call it first, outer, inner, and last. And it's just kind of an easy way to remember the steps and how to do this. So let me rewrite this one. So we've got x minus 4 times negative 4x minus 5. Okay, and what we're doing here is basically distribution, right? Because if I took this and times it by that, we would just distribute the x, right? Same with this second piece. And that's basically what we're doing here, okay? But we're doing it in an order that this FOIL kind of just reminds us so we don't miss anything up. Miss anything or mess anything up, and kind of combine that. So the first represents the first term in each group, in each binomial, because there's 2 of them. So I'd go x times negative 4x. X times x is x squared with the negative 4 out front. Then the outer represents the 2 pieces on the outside. Okay, so that would be x times negative 5, which would be a negative 5x, or minus 5x. The inner now is the two pieces in the middle. Okay, I guess I forgot to draw the combiney line. Okay, I've heard it called other things, but FOIL is the one that I've really used. Okay, so negative 4 times negative 4x. Negative times negative is a positive, so positive 16x. Okay, then the last would be the last pieces in each one. So negative 4 times negative 5, which would be a positive 20. And then we combine any like terms, which typically the middle ones end up being. So negative 4x squared stays. Negative 5x plus 16x is a positive 11x plus 20. And there is my new function. Okay. So that FOIL is kind of the way that I would suggest doing it for the most part. You can, I guess, if you really understand it and think of shortcuts, you could go, well, 3x times x is going to give me 3x squared. 3x times negative 3 going to give us negative 9x. Then negative 5 times x is going to be negative 5x. And then negative 5 times negative 3 is going to give us a positive 15, which basically we're doing the same thing that we did over here, just not quite so fancy looking. Combine like terms, we get 3x squared minus 14x plus 15, and there is our new function. Okay, so that's when you're dealing with ones like that you would want to use the FOIL, right, where you have two binomials. Okay, if you have something different like 23 and 24 and 25, makes it a little easier, doesn't it? Because now you're just going n squared plus n, h of n times g of n, which is 2n. So here I just distribute. So 2n times n squared is 2n cubed, and 2n times n is 2n squared, right? Can't combine those. There's my result. Okay, so those ones are a lot easier to deal with, aren't they, than the other ones, because we just have to distribute. So 3a times a squared, 3a cubed, 3a times negative 3a be a negative 9a squared. Can't do any more to that. 25, same idea. X minus 5 times 4x, 4x times x be 4x squared, 4x times negative 5, negative 20x. But again, if we have this one with the two binomials, 4n minus 3 times n minus 3, so I do our first 4n times n, which is 4n squared. Our outer, 4n times negative 3, negative 12n. Our inner, negative 3 times n, negative 3n. And our last, negative 3 times negative 3, which would be a positive 9. Combine like terms, we get 4n squared minus 15n plus 9. And there is our next one. Okay? Then we just have a lot more, don't we? Okay? And then we've got some with the letters, so looks like we've got 6 with, not letters, numbers. So these last two. So again, we can go 3t times 2t, which would be 6t squared. 3t times negative 5. And sometimes it's really good to write it out so you remember which ones you're actually dealing with. And negative 1 times 2t, which would be negative 2t. And negative 1 times negative 5, which would be positive 5. Then combine the like terms to get negative 17t, then plus 5, and 6t squared. Okay? So, there's not really an easier way that I can think of to talk to you about it, other than setting it up like this and doing your problems this way, because it just is kind of the easiest way to do it. Now this one, notice we're not going to be able to have any like terms, are we? Because of the way that they were written. So, but what we want to do is put the highest power first, followed by the next, then the last variable, then the constant. Okay. Now, with when we have the actual evaluate numbers, okay, we can do the same thing we were doing. 4x plus 3 times negative x, get negative 4x squared minus 3x, and then plug a 1 in there, so negative 4 times 1 squared minus 3 times 1. 1 squared is 1. Negative 4 times 1 is negative 4. 3 times 1 is 3. Negative 4 minus 3 gives us negative 7. Or this is where I think it's easier to evaluate. Because then we just go g of 1 equals 4 times 1 plus 3. 4 times 1 is 4, plus 3 is 7. G of 1 equals 7. H of 1 would equal negative 1. That was easy. So then we just go 7 times negative 1, and we get negative 7. See, I think this is the case, really, where it's a lot easier to deal with it, especially the more complex type of problem you have, where, yes, you've got to deal with all pieces. Okay, and you have to do this whole big thing right here, right? And then we're going to plug in, I believe that's 3, right? Yeah. Then we're going to plug in our 3, so 8 times 3 squared plus 2 times 3 minus 6. 3 squared is 9. 8 times 9 is 72. 2 times 3 is 6. Minus 6, those cancel. We're left with 72. So it's not so bad when you know what you're doing, like me. Okay, I'm able to do that pretty quick. But I think it's just a lot easier to evaluate and get your information that way. Just you're dealing with the smaller numbers generally, and then it's just a matter of going g times h, and you get your result, which is the same. So I think that way is just easier. So that's the way I'm going to do the rest of these, because that's the way I want you guys to do these ones. Okay, so g of x would be g of negative 4 equals negative 4 times negative 4 minus 1. Negative 4 times negative 4 is positive 16, minus 1 is 15. So I know g of negative 4 is 15 times, now we do h of negative 4, so negative 4 squared plus 5. So that negative is outside the x squared. So negative 4 squared is 16. Bring that negative. Negative 16 plus 5 is negative 11. So h is negative 11. So then I just have to simply go 15 times negative 11, and we get negative 165. Okay. 32, same idea. Putting in negative 1. 3 times negative 1 minus 3. 3 times negative 1 is negative 3. Minus 3 is negative 6. So g of negative 1 is negative 6. Then h, negative 1 cubed, plus 5. Negative 1 cubed is still negative 1. Plus 5 gives us 4. So we've got a positive 4. Negative 6 times positive 4 is negative 24. Okay, and the last two. So 2 times 2 plus 5, which give us 10 plus 5, or 15. So f of 2 is 15. A squared would be 2 squared minus 2. 2 squared is 4, minus 2 is 2. G of 2 is 2. 15 times 2 gives us 30. And finally, 2x. 2 times negative 4 gives us negative 8 for h of negative 4. Then 3 times negative 4 plus 5 gives us negative 12 plus 5, which is negative 7. So g of negative 4 is negative 7. Negative 8 times negative 7 is a positive 56. Okay, so there's how we evaluate, combine those functions for multiplication or add, subtract, and multiplication. Alrighty?